Good morning, students. I know you guys are the ones who are working on your own. So I want to create a video for today's lecture. Today's lecture is titled Tuesday, September 15th, 2020. And this is on Google Classroom that I'm reading off of. You're going to be doing two sections, okay? And every day we write a journal. And it's an easy grade. All you got to do is write 4 sentences. Don't forget. So you have journal 1 from yesterday, journal 2 from today, and on Friday you'll be turning all 5 in. Excuse me. So first thing is I will be introduced to scientific notation and review length and volume. I will use my skills to identify and discuss steps to writing scientific notation. And then we're going to talk a lot about examples for length and volume. And then obviously, I'm going to cut myself off, but I expect you guys to be doing the review questions after each section. Okay, so let's get started. The first topic that we're going to be talking about, and here is your assignment. You're supposed to do your daily journal, and then we're going to start reading 3.3 scientific notation and 3.4 length and volume. Okay. So first things first is scientific notation. Remember, if you don't want to use the CK12 links, I do have the PDF version here. Okay. So scientific notation. Scientific notation is really, really easy to use and to do. All you need to do is learn the steps, and the steps are really, really easy. So let's talk about how far is the sun from the earth. Okay, and the first thing that they say and they talk about is the moon. The moon is only 406,697 kilometers away from earth. Okay, and the sun, look at that, the sun itself is 150 million kilometers. Those are very large numbers. If we look at the closest star that is not the sun, we talk about it being 39. What is that? This is million, this is billion, 39 trillion kilometers away. Okay. And those are very large numbers, and that the scientific notation helps us make those numbers a lot more manageable. Scientific notation also helps us with very small numbers. For example, fungus, those little mushrooms that grow after it rains or on top of cow manure. Well, those fungus can be as small as 30 micrometers or 0.000030 meters in length. The viruses, on the other hand, like COVID-19, they could be as small as 0.03 micrometers or 0.000003 meters long. Okay. Okay, so where were we, students? So if you look, we were talking about the fungus. Now viruses, on the other hand, are 0.000003 meters long. Now scientific notation makes expressing these very large and very small numbers so much easier using the power of 10. Okay, and we're going to talk about an example first. We're going to talk about the sun example. So if you have 150 billion meters and you're trying to put it into scientific notation, well, let's go here to Jamboard. Okay, now Jamboard, I'm going to just put the example that they gave us, 150 billion. Oh, I missed a zero. Kilometers. Okay. Now we need to make this example into scientific notation. The first thing I need to do is I need to look at my numbers here. I need to make that number bigger than 1 but smaller than 10. So what I'm going to do is I can't put it after the 5 because 15 is too big. I can't put it before the 1 because 0.15 is smaller than 1. So what I'm going to do is I'm going to put a little decimal between the 1 and the 5. And then I'm going to rewrite it down here, 1.5. Now this times 10 is always there. Now the only thing you need to figure out is the exponent, the little number on top next to 10. So originally my decimal was over here way in the back, and I need to count how many times it takes me to get to that decimal. Okay, this was 1, 2, 3, 4, 5, 6, 7, 8. So 8 becomes my exponent and then my unit. And then this is my final answer. Okay, that is the example. And then you could see it back where you have it right here, 1.5. Oh, I must have missed some zeros because it's 11 instead of 8. Oh, I think I put trillion and not million. So we just missed a couple of zeros, okay? I was missing a couple of zeros here. Okay, so there's this 11 instead of 8. And that was my bad. Either way, this is correct for this number, okay? And that's just an example. Remember, your coefficient, the number in front, has to be bigger than 1 and smaller than 10. Okay, and then you're going to have to figure out the exponent. Okay, identify where the decimal is before, where it is now, so that the number is between 1 and 10, and then count the difference. Now, exponents can not only be positive, but they can be negative. And the example that I'm going to use is the one about the fungus, this 0.333 meters. So we're going to go back to Jamboard. We're going to clear the frame, and we're going to put the number that they have, 0.000030. Okay, now I got to look here where my numbers are. Where is this number bigger than 1 and smaller than 10? I can't put it in front because 0.3, no, will not work. It's not bigger than 1. I'm going to put it here mostly because 3.0 is bigger than 1 but smaller than 10. So that's where it's going to be. Now I need to count 1, 2, 3, 4, 5. So when I write my scientific notation, I'm going to put 3.0 times 10 to the 5, but this time instead of it being positive, it's going to be negative. Okay? It's only negative if if the zeros are on the left side. If the zeros come on the right side behind it, then it would have been a positive 5. All right? So that's scientific notation. The zeros in front are known as leading zeros. Basically, the zeros to the left of the decimal point, the digit that's there to help to see your decimal point more clearly. Okay, and then they give you examples. All right, these are your review questions that summarize. Scientific notation always allows us to express very large or very small numbers in a very convenient way, in an easy way. Remember, when you're doing your coefficient, your number has to be between 1 and 10, and then you're going to put times 10, the power of 10, and then you're going to tell me how many times it takes to get from the original decimal place to where you put it so that you can make your coefficient between 1 and 10. Okay? Try these out, see what you can do, and then turn them in. All right, that's section 1. Now we're going to go to the next section, 3.4. So before we get started, let's talk about how sailors used to determine the depth of the sea. Now, what they used to do is that they would tie knots every 6 feet. I always thought it was so that in case anybody ever fell over, they can easily get up. Well, I was wrong. Okay, I was really, really wrong. What they used to do is that every 6 feet they would tie a knot, and then they would drop the rope down and count how many knots it would take before the rope hit the bottom. And that's how deep it was. Today, we have it super easy. All you have to do is just hit a button, and the a machine will tell you how deep it is. So let's talk about two very important two important units that we use, or two different variables that we need in chemistry: length and volume. So first off, you have to remember that length is talking about the greatest dimension. So let me go to Jamboard. Let me clear. If I have a box or a rectangle, this longest side right here, that is the greatest dimension. It is the longest end. It's not the width, and it's not the height and all that good stuff. So if they're asking me, okay, which one of these is it, the width, is it the height, or is it this way? Is it vertical? Is it horizontal? Or is it the one going back that's the length? Well, I would say it's the one that's going across, because you can see very obviously that it's the longest end. That is how you determine length of an object, or how you decide. The SI basic unit for length is known as the meter. We can use the prefixes from yesterday's assignment to make our meters very, very large if I'm talking about a big distance, like from New York to Chicago. Or I can use those prefixes to talk about meters in a smaller version, especially when you're talking about human hair being only 20 micrometers. Volume is the amount of space occupied by a matter, okay? So volume is very, very important, especially in chemistry, because it tells us how much space an object takes up. Now, if you have a regular shaped object, like the rectangle that we're talking about, the box, we can easily figure out the volume if we use the length, the width, and the height, and then we multiply. Okay? That would be the volume of the object. Okay? If you have a box that measures 1 meter on each side, and you do length times width times height, it's going to equal what's known as a cubic meter. Basically, you said 1 times 1 times 1 times 1 equals 1 m to the third power. In chemistry, we like to use liter for volume. If for some reason your cube is 10 centimeters long, when you multiply each side, you're going to get 1 decimeter, and it should be decimeter cubed. I don't know why or 1 decimeter in length, actually. If it's 10 centimeters or 1 decimeter in length each side, your volume will be 1 to the decimeter to the power of 3. If you have a box this is the version in centimeters. If you have 10 centimeters times 10 centimeters times another 10 centimeters, it's going to be 1,000 cubic centimeters. We also talk a lot in terms of milliliters versus liters. Always remember that the L in liters should be capitalized. Please remember that a milliliter is equal to a cubic centimeter, and that's cm to the power of 3, as you can see there. If you have a water bottle, normally it's 1 liter in volume. Here you have an example of a cube, a Rubik's Cube in this case, that has a length of 5.7. So it's 5.7 across, down, and across the other way. And if you multiply those three numbers, you'll get 182.5 milliliters in volume. The instrument that we use for volume is known as a graduated cylinder, and here's your example. Here you have your summary. Length is the measurement or the extent of something along its greatest dimension. Its longest length, basically. Okay? If you have 3.2, or if you have, for example, and let me clear this. If I tell you that you have a box that is 2.1 meters times 4.7 meters times 9.6 meters, and that's a point, sorry. And I ask you which one is the length. Well, you're not going to choose 2.1 because it's smaller than 4.7. And you can't choose 4.7 because it's smaller than 9.6. So if I had to decide which one would be my length, I would say it's the last one because that's the longest dimension. Okay? And that's going to help you with one of the questions. And then everything else is in the reading. All right? Good luck, and please turn this in as soon as you're done. All right. Have a wonderful, wonderful day. And thank you for listening. Bye bye.